Well, now I am going to give a proposal for our final project. Our group consists of two members, Hong Xinyang and Lan Tingxie. Well, the purpose of our final project is to make an application that can help recommend the best route to desired destinations in Calgary for our users. As is mentioned in our purpose, we are aiming at designing the best route for our user. The best here means the safest and the fastest. In order to achieve our goals, there are a few problems we need to consider. Here comes the problems to solve. Well, one of the problems is people's heavy request on the use of private cars. Although there are numbers of public transportations for people to choose nowadays, many of them would still prefer private cars when going out, as it is much more convenient than public ones, especially when you are going out with kids and elders. However, this gives rise to other problems: heavy traffic congestion and increasing numbers of traffic incidents. Well, heavy traffic congestion makes the time spent on commuting become a lot longer, and the increasing numbers of traffic incidents shows that people should pay more attention during driving. And these are all problems waiting to be solved in our project. In order to solve these problems, we will import some techniques from the spatial trajectory processing in our application. Well, here is the first one. The first technique we are about to use is unsupervised learning. Well, it is used in trajectory-based activity recognition in order to discover some useful activity patterns. This technique takes only the trajectory data as input and does not use any activity label information. Therefore, the outputs of these models are some data clusters or low-dimensional feature representations. The outputs may not correspond to exact activity labels, but may imply some underlying activity patterns. In the process, we will mainly use two open datasets. Well, the first one here is Open Data Traffic Incidents. Traffic incidents is an archive of traffic incidents within Calgary updated every 10 minutes, which means the dataset is really up to date. Well, here on the right of the slides is an example of the data in datasets. Well, you can see here it consists of the addresses and the coordinates of the location where incidents took place. Well, here is incidence info is the address, and here is longitude and latitude is the coordinates. And you can see there are also descriptions of all the incidents, such as two vehicle incidents, multiple vehicle incidents, and there is an incident involving a pedestrian, traffic signals are flashing red, crews have been dispatched. Well, the use of the data can help us decide the safety level of each area when using unsupervised learning method. Well, which means the area with more incidents will be marked as less safe, and areas with fewer incidents will be marked as safe. And then comes the second open data. The second one is 2019 Traffic Volume Flow Map. The traffic volume flow map illustrates the average annual weekday traffic, the average number of vehicles in 24 hours adjusted for seasonal variation to represent the average weekday. The numbers on the map are two-way totals. Here on the right is also a picture of the dataset. The roads are colored differently according to the traffic volumes of each road. Blue here stands for low traffic volume, while orange stands for high. The use of the data can help decide how busy each area is by using unsupervised learning method. And then comes the second technique. The second technique is making roadmaps from trajectories. The whole process can be divided into two steps. The first step is we need to clarify the GPS traces in an effort to mitigate the effect of measurement noise. Our goal is to group together traces and points that belong to the same road. Then, we will separate traces that belong to different directions on the same road. This step is aiming at simplifying the process of creating a traditional graph representation of the road network. And here comes the second step. We cluster the clarified traces into discrete roads represented by a graph with nodes and edges. A simple graph generation algorithm will be applied to describe the connectivity and geometry of the road network. The process of this algorithm can be described as follows. Given the set of clarified GPS traces, we process the trips sequentially and build up the graph incrementally. For each trip, we process the trace nodes in time order. For each trace node, we search the graph and decide whether it should be merged with an existing graph node. If so, we merge the trace node with the target node. Otherwise, we create a new graph node. Then the road network represented by nodes and edges will be completed. And here are all the techniques we're about to use. And then comes to the next part, the design of the application, which is pretty important in our project. Well, here comes to the main page. The main page of the application is a map of Calgary, on which user will be able to see the identification of the safety levels of different areas and the identification of the traffic volume data. Well, this can give user a close look at the traffic condition in Calgary to help them get to know how busy each road is through traffic volume data and the places they need to be careful when driving through the safety levels of the area. And then the next part is the use of RESTful API. Well, Django will be used in the project. A database will also be used and linked to help achieve the function of register and login and make it possible for the designer to manage the information of the user. Also, the function of choosing the best route will also be achieved through the use of RESTful API. And then is the most important part in the design, the main function of our application. Well, for the map page, after pasting the link to the browser, the user will be able to see the map of Calgary, which is exactly what is mentioned earlier. The map is open to everyone, which means the login process is not needed to see the map. And then comes the login and logout section. This is also pretty important since the function of the application can only be used after login. If the user is new to the page, then the sign up step will be needed before trying to log in. And after logging in, the user will get to a page with a search box, which is the search function here. Well, in order to use the search function, the user needs to choose the starting point and the destination first and click on search button, then the route designed by the application will be shown on the screen. Additionally, for the request of interactive, a warning message will be added to the application. As long as the user moves their mouse to place with high risk, which means places with more traffic incidents, A warning message will appear to remind the user to be careful when driving through. Well, that's the end of the proposal, and thank you for listening.